Hi, I'm Kian, and today I want to teach you how to find if a sequence is convergent or divergent. I previously introduced you to the convergent sequence and divergent sequence, and I told you that convergent sequence are sequences that if we take the limit of that sequence as x approaches infinity, that sequence approaches to a finite number or an actual number, like 1, 2, or 0. But divergent sequences are sequences that if we take the limit as x or the variable approaches infinity, that expression or that function approaches to infinity, which is not a finite value. So let's say we have a sequence t sub n equal to 2n squared plus 3n plus 1 over n squared plus 2n. So we want to find if this sequence converges or diverges, or it's a convergent sequence or divergent sequence. So we take the limit of 2n squared plus 3n plus 1 over n squared plus 2n as n approaches infinity. What we do is that in limits as n approaches infinity, we divide the numerator and denominator by the highest degree. In this case, the highest degree is n squared, it's 2. So we divide this value by n squared over n squared. This has no impact because n squared over n squared is just 1. But we want to simplify the expression to take the limit easier. 2 over n squared is just, let me write the limit. 2n squared divided by n squared is just 2 plus 3n divided by n squared. N cancels and then we get 3 over n plus 1 over n squared over n squared divided by n squared is just 1. 2n divided by n squared is just 2 over n. Now we want to work with these three values: 3 over n, 1 over n squared, and 2 over n. If we take the limit of 3 over n as n approaches infinity, different from this, we see that this expression approaches to 0. That means if we put 3, we get 1. If we put 2, we get 1.5. If we put the 1, we get 3. We see that this value is just decreasing and decreasing, and it will reach 0. So we can put 0 instead of 3 over n because it converges to 0. This is also the same for 1 over n squared. This sequence also, this expression also converges to 0. If we put 1, we get 1. If we put 2, we get 1 over 4. If we get 3, we get 1 over 9. This value gets smaller and smaller and get closer to 0. So we can put 0 also for this. Also for 2 over n, this also converges to 0. If we put 1, we get 2. If we put 2, we get 1. If we get 3, put 3, we get 2/3. This value is just decreasing and decreasing. Put 0. 2 plus 0 plus 0 is just 2 over 1 plus 0 is just 1. So this sequence converges to 2. That means it is a convergent sequence. Let's try another example. Let's say we have t sub n be equal to 3n squared minus 2n over n minus 1. So we want to find if this sequence is convergent or divergent. As I told you, we take the limit of 3n squared minus 2n over n minus 1 as n approaches infinity. Then, as I told you, we divide the expression by the highest degree, which in this case is n squared. N squared over n squared. If we do that, we get the limit 3n squared divided by n squared is just 3, minus 2n over n is just minus 2 over n, over n divided by n squared is just 1 over n, and minus 1 over n squared as n approaches infinity. So we are working with these three values. 2 over n, as I told you in the previous question, is converges to 0. If we put different values for n, we see that it gets closer and closer to 0. So we can replace it with 0. 1 over n also is the same. If you put 1, we get 1 over 1, which is 1. 2, we get 1 half. 3, we get 1/3. This value is just getting smaller and smaller, and it converges to 0. And this is the same for 1 over n squared. This also converges to 0. So we finally get 3 over 0. 3 over 0 is just undefined. We all know that 3 over 0 is equal to infinity. We can't divide any number by 0. So this is undefined, or is equal to infinity, which is not a defined number. So we can conclude that this sequence is divergent. That means it doesn't approach to a finite or actual number that exists. Thanks for watching. Please subscribe and let me know what you do next.